41. Show that A union B closure is equal to A closure union B closure. So the goal is to show that these two sets are subsets of each other. So let X be an A union B closure. The goal is to show that X is also an A closure union B closure. So we're going to do a proof by contradiction. So we're going to negate this. So let X not be an A closure, and X is not in B closure. Okay. So we know that since X is not in A closure, this means that there exists some open set such that G intersection A is the empty set. And we know that X is also not in B closure. So same thing. So since we know that G intersection A is the empty set and G intersection B is the empty set, combining these two together, you get G intersection G and B, so A and B, so we get A intersection B, which is the empty sets. Since G intersection A intersection B is the empty set, we have two possibilities. So there exists some Y from the previous modules. We know that if these two sets intersection be empty set, then either there's something in G complement intersection A intersection B, or there's something in G intersection A intersection B complements. And we're going to go with this statement. So, since there's something in G intersection A intersection B, so that means there exists an open set if we break this down, this turns into either G intersection A complements or G intersection B complements, which means X is in either an A closure or X is in B closure. But we assume that X cannot be in A closure and X cannot be in B closure. Because if X can appear in A closure or B closure, how can it appear in either of these closures? So we found a contradiction, which means then X is in A closure or X is in B closure. And this implies that X is in A closure union B closure. And that'll be it for this. So we're going to prove for the other way. Let X be in A union B closure. So the goal we need X to be in A, U, B closure. So, since we can say that A is a subset of A, U, and B, and B is in the set of A, U, and B as well. If we take the closures of both sides, this preserves containment. So we can say that A closure is in A, U, and B closure, and B closure is also in A, U, and B closure. If we combine these two together and union them, so if we union A, U, and B is a subset of A, U, and B closure. Therefore, X is in A, U, and B closure.